Now, machine learning models can be represented in various forms, such as decision trees. We are talking about different models that are common in machine learning. We're talking about decision trees. Linear regression is a model. We have ensemble models. We have support vector machines, neural networks. Now, remember that each model represents the learned relationships between the input features and the output labels using different mathematical algorithms or architecture. So you have to take note of this, that after your model, those models are a mathematical representation of a particular algorithm. So another concept that we will be talking about in machine learning is the model training. Model training involves feeding the training data to the machine learning algorithm or model to learn the underlying patterns. Now, the algorithms will adjust the model's parameters based on an optimization process. For instance, minimizing the error between the predicted and the actual labels to improve its performance. Then we also, in machine learning, we talk about model evaluation and validation. So after training, you are dividing your raw data. The raw data that has been given to you, you are splitting them into two. Now you are going to have what you call the training set and the test set. So after training your model, you need to evaluate and see if the model performed exactly the way you wanted it. So that is where model evaluation and validation comes in. Do you get it now? So you need to evaluate it with unseen data. You get it? You have trained your model, of course. How would you be able to ascertain the validity of your model? That is where model evaluation and validation comes in. So evaluation metrics like accuracy, precision, recall are used to measure how well the model performs and to compare different models. Then the next concept in machine learning is model testing and deployment. Now you have evaluated your model. Your model is able to perform exactly the way you wanted it. So the next thing is your model testing and deployment. So once a model is trained and validated, it can be tested on new unseen data to ensure its effectiveness. The model can then be deployed to make predictions or classification on real-world data. That is the essence of data science. Now, after you have been able to create a particular model that is suitable for the task you want it to perform, then the next thing is to now test that model on real-world data. And that is what this class is all about. So we will be doing the practical. I'm going to show you the various ways by which you can implement all these ideas. Now, the next concept in machine learning is overfitting and underfitting. Now, what is overfitting? Overfitting usually occurs when a model learns the training data too well, resulting in poor generalization to new data. That means your model performs well on your system, but it cannot, when you want to test it outside your own system, it couldn't be able to predict anything. That means overfitting has occurred. Underfitting happens when a model is too simple to capture the underlying patterns in the data, leading to what we call suboptimal performance. The model didn't perform well. The model is too simple to handle complex tasks. That is underfitting. Now, balancing between overfitting and underfitting is crucial to achieve a model that can generalize well. Now, machine learning is very vast field. Take note of this. With various algorithms, various techniques, and even applications. These fundamentals provide a starting point for understanding the key concepts and processes involved in machine learning.